Okay, students, you're welcome. This is Campus Academy, um, where we simplifies everything. Where we simplifies physics, chemistry, math, technical drawing, uh, for A level and for O level. Okay, we started. We started with NECO, uh, NECO 2021. Um, the first part has been done. The objective questions from 1 to 60. First part has been done, 1 to 20, which I've uploaded. Second part has been done, 21 to 40, which I had uploaded. And the third part is going to be from 40 to 60. So 40 to 60. So when we are done with this 40 to 60 objective part, then we move to the theory aspect of it. As you can see, this is the NECO past question. So once again, you're welcome. Thank you for being there always. Please don't forget to click on the subscribe button so that you can see the videos I've uploaded for part 1, part 2. So this is the last part. Okay, so we are going to finish it today from 40 to 60 by God's grace. So, and then you feel free to call or message or WhatsApp on 09074526311. You can WhatsApp, you can message, text message, and you can call on this. Okay, let's see how far we can go here. Let's start from number 41. 41. Yeah, an atom X with the electronic configuration 1s2, let me write it on the board, 1x2, 2s2, 2p6, 3s1. Say an atom X with this electronic configuration 1s2, 2s2, 2p6, 3s1 belongs to what period? And then we know that elements in the periodic table are positioned based on their atomic numbers. So this particular element X as given. So for you to get the atomic number of this element, we have to sum up the numbers at the top. The indices numbers. You have to sum them up for you to know the atomic number. Though you're going to find the period to which it belongs. First and foremost, we have to know the atomic number. That's 2 plus 2. That's 2 plus 2. Okay, that is 4. 4 plus 6, that's 10. 10. Then 10 plus 1, that's 11. So it has atomic number 11. So this element X has atomic number 11. Are you there? So you can now distribute it into shells. The first shell will take a maximum of 2 electrons. Are you there? The second shell will take a maximum of 8 electrons. That's 8. So 2 plus 8, that's 10. So we still have 1 more left from 11. Then the third shell will take the remaining 1 electron. So we are having as 2, 8, 1. First shell takes maximum of 2 electrons. Second shell takes maximum of 8 electrons, and the third shell takes maximum of takes the remaining 1 electron. So first shell, second shell, third shell. So the number of shells represent the period to which the element belongs. So the number of shells represent the periods to which the element belongs. But the valence electrons, the electrons at the outermost shell, will give you the group of the element, the group to which the element belongs. Like this one now, the valence electron, the electron at the outermost shell is 1. That means this element belongs to group 1. Then the number of shells represent the period to which it belongs, 1, 2, 3. So it belongs to period 3. So the question says an atom X with the electronic configuration 1s2, 2s2, 2p6, 3s1 belongs to period. Option A 1, option B 2, option C 3, option D 4, option E 5. So option C is the correct answer, 3. So let's move to number 42. Number 42. Don't forget that I also specialize on home tutoring. Okay, still that same number you can WhatsApp or you call. So home tutoring will be there live and direct. So number 42, which of the following methods is suitable for separating petroleum fractions from crude oil? Which of the following methods is suitable for separating petroleum fractions from crude oil? Option A, which of the following methods is suitable for separating petroleum fractions from crude oil? Option A, chromatography. Chromatography is wrong. Chromatography is a separation technique that is used to separate the constituent of a colored dye, of a colored substance, the constituent of a colored substance. So a colored substance can have different colors: yellow, red, blue, green. So to get those different colors out of that colored substance, you use chromatography. That one is wrong. Option B, evaporation. So evaporation is the process of recovering a solid, a soluble solid from its solution by heating, if the substance will not decompose on heating. So that's evaporation. Option B is wrong. Option C, filtration. You use filtrations to recover a solid, an insoluble solid from its solution, So that one is wrong. So option D, fractional crystallization. If you have a solution that contains two or more soluble salts, you have a solution that contains two or more soluble salts, and you want to get all of them out one after the other, you use fractional crystallization. But ordinary crystallization is when you have only one soluble salt in the solution and you want to obtain it back. Okay, that is not the answer. But option E, fractional distillation. You have a solution that contains two or more soluble liquids, like ethanol and water. Both of them are soluble in water, and you want to recover ethanol, you want to recover water. From there, you use fractional distillation. So at the same time, we consider crude oil. Crude oil is a mixture. So it contains different chemical substances, a lot of liquids and all that. Do you understand? In order to separate to obtain the constituent of crude oil, we normally use fractional distillation. So that is what is used in oil industry. Fractional distillation is what is used in oil industry to obtain the constituent of crude oil, which are naphtha, kerosene, diesel, and residual oils. Residual oils could include the lubricating oil, bitumen, and all that. So fractional distillation is our correct answer for number 42. 42E. So let's go to 43. 43. The process involved in the decomposition of sugar by an enzyme is what? The process involved in the decomposition of sugar by an enzyme is what? Don't forget that my explanation here will help you in other exams. Are you there? Like JAM, like WAEC, like IGCSE, chemistry, and all that. Do you understand? So the process involved, you can just some point, the process involved in the decomposition of sugar by an enzyme is what? Option A, dehydration. Dehydration is not the correct option. Dehydration is a process of removing water molecules from a chemical substance, and in which the chemical composition of that substance is affected. But drying, For drying, well, drying also involves removal of water molecules from a substance, but in which the chemical composition of that substance will not be affected. Will not be what? Affected. Okay. So so option A is wrong, dehydration. Now option B, esterification. Esterification is the process by which an alkanoic acid reacts with an alkanol in the presence of a mineral acid as a catalyst to yield ester and water. So that is not what we're talking about here. So option B is wrong. Option B is wrong. Now let's go to option C. Option C, yes, fermentation. Yes, fermentation is the correct option. So fermentation is the process by which large organic molecules are broken down into small organic molecules by the action of enzymes. By the action of enzyme. Look at starch. Are you there? Starch is a large organic molecule, so it can be broken down into ethanol by the action of different enzymes. For example, we have starch. So starch, okay, starch will be acted upon by the enzyme diastase or invertase. Diastase or so diastase. So to give maltose. To give maltose. Are you there? Then the maltose, for the maltose, the enzyme maltase, are you there? We act on maltose. To give glucose. Okay? Then the enzyme glucose will be acted upon by the enzyme zymase. Are you there? By the enzyme zymase to give ethanol and carbon 4 oxide. So carbon oxide will come as effervescence. A gas is evolved. So this is starch is a large organic molecule that has been broken down into what? Ethanol as the small organic molecule in the presence of all these enzymes. Are we together? So fermentation is the correct answer. So D. Let's look at D. Option D say polymerization. No. Polymerization is the process by which two or more monomers are combined together to form a polymer. So the monomers could be the same and they could be what? Different. Are you there? So for example, the monomer of protein is amino acid. So amino acid is a monomer, protein is a polymer. So that means thousands of amino acids combined together, are you there, to form protein polymer. So polymerization is wrong. Option E, saponification. Saponification is a process by which fat or oil react with caustic soda to produce soap and glycerol. So option E is wrong. So our correct option is what? Option C, fermentation, for number 43. All right, we are progressing. Let's go to number 44. Number 44 now. Number 44. Now 44 says, an organic compound which reacts readily with bromine to form a compound with the formula CH3CHBrCH3 is what? Let me write the formula on the board. CH3CHBrCH3. So an organic compound which reacts readily with bromine to form a compound with the formula CH3CHBrCH3 is what? So we are given different options. We are given option A, butane, option B, ethene, option C, propane, option D, propene, option E, propine. Option A, butane, option B, ethene, option C, propane, option D, propene, option E, propine. So we are having, first and foremost, look at how many number of carbon atoms are we having in the formula. Carbon 1 here, carbon 2 here, carbon, that's 3 carbon atoms. So you should think of anything prop, anything prop, anything PRP. Are you there? So because you're having 3 carbon atoms, 1, 2, 3, PRP, prop, because it is bromine that is reacting. Are you there? Bromine is reacting. Okay, so prop 1, 2, 3, 3 carbon atoms. So option A is butane. Butane has 4 carbon atoms. That is C4H10 from the general molecular formula of alkane, CnH2n plus 2. Okay, so butane is C4H10. So it has 4 carbon atom. When you look at this CnH2n plus 2, this is general molecular formula of alkane. So butane is when N is 4. So when you put 4 here, that's C4. Then 2 times 4 here, 8. 8 plus 2, 10. So butane has 4 carbon atom, which is C4H8. So C4H10. So since it has 4 carbon atoms, so it's out of the option. So butane is wrong. Option B, ethene. The molecular formula of ethene is C2H4. So ethene has 2 carbon atoms, so we cancel out that. So option B is wrong. We are going for the one that has 3 carbon atoms. So option C, propane. Propane, we have 3 carbon atoms. Option D, propene. Propene, we have 3 carbon atoms. Option E, propine. Propine also have 3 carbon atoms. So you are left with propane, and propine. So let's begin to cancel out. Propane is our final answer. But let me explain the reason why we are cancelling out propane. Propane is C3H6. Propane is C3H6. Are we together? C3H6. So this C3H6 now, let me write the structural formula. So I will see C3H6 propane. So propane is under the homologous series alkane, ALKENE, alkane, whose molecular formula whose molecular formula is CnH2n. Okay, so for propane, the carbon atom will be N will be 3, so we have it as C3H6. Okay, so if it comes this way, we have 3 carbon atoms, 1, then we have the 3 carbon atom, then we have double bond, because it is alkane have double bond, either they have double bonds, okay, as a functional group. So we have carbon here, 1, 2, 3, 4. We have carbon here, 1, 2, 3, 4. We have carbon here, 1, 2, 3, 4. So these bonds represent hydrogen. So each carbon atom takes 4 bonds around it. It is tetravalent. So how many hydrogen? 1, 2, 3, 4, 5, 6. That's 6 hydrogen. How many carbon? 1, 2, 3. 3 carbon atoms. So once you add bromine to this, if you add bromine, are you there, in form of a gas, are you there? So what you are going to have? Okay, let's go. So it means that we need this alkane undergoes addition reaction. They undergo alkanes undergo addition reaction with hydrogen, with halogens, either with bromine water and all that. So this one is bromine is an halogen, either. So let's see how we can get that out. So if we had to write the product, that means one of the bromine we remove this double bond. One of the bromine, so we remove, so one will come here, another one will come here. So we have carbon. Look at this carbon, 1, 2. I'm writing this, which is this one, either. Then to carbon, which is this, hydrogen at the top. Okay, now so we need one more element here, are Are we together? One more element here. So we put one more element here, which is one of the bromine. So bond, bromine. Then this double bond becomes single bond. Because we have added another element. So becomes single bond. Then this carbon here, and write it carbon. Then the hydrogen at the top, hydrogen. Then hydrogen beside hydrogen. Then so something is missing here. There was no element here before. Are you there? So since we have turned this double bond to single bond, so we must put one element here, and that one element will be the second of the bromine. Second one of bromine. That's Br. Are we together? So at the end of the day, you'll be having CH3 as the when you write this one together, CH3. Then this one becomes CHBr. Are we together? CHBr. Then this one becomes CH2Br. So can you see that this CH3, CHBr, then CH2Br is not the same thing as this. It's not the same thing as what we are given. Okay? So that's what I said. This one will give you 1,2-dibromopropane. Okay, 1,2-dibromopropane. But we're having only one bromine in the question. So it's not possible for you to have one bromine in the reaction here, and the other bromine will not stand alone in the product. No. So alkenes undergoes addition reaction. So propene, that is option D. Propene is wrong. The option E, propine, the same thing. Propine will even be worse. Propine will be worse because propine will require, we need 4 atoms of bromine. 4 atoms of bromine, which means 2 moles. Of bromine. Do you understand? So propine will be worse. Propine will be having, by the time I write the structure, the chemical structural equation for bromine, I found that it will need 4 bromine. This one needs 2 bromine. The propine we need 4 bromine. Either. So which will not be the answer. So option C, propane, which is the third member of alkanes as an homologous series. Either alkanes. So propane is the third member. Either. So when you look at the formula for propane from alkane, which is CnH2n plus 2. CnH2n plus 2. So propane, N is 3 because it's third member. So that gives us C3H, 2 times 3 is 6. 2 times 3 is 6. 6 plus 2, 8. So C3H8, that's propane. So all alkanes undergo substitution reaction. So substitution reaction. So we are going to have it in this form. Let me write the structural formula. For C3H8 alkanes. Can we have it? Okay, let me clean this other one. C3H8 alkane. C3H8. So that's 3 carbon atoms. 1 carbon, 2, then carbon 3. Okay. H here, hydrogen. So this is C3H8. So by the time it reacts with bromine, that bromine is bromine gas. Are you there? So is the atomic. You find that all alkanes are saturated already. They are saturated hydrocarbons, so they do not undergo addition reaction. They only undergo substitution reaction because it's complete already. Or look at each of the carbon atoms. Each of the carbon atoms have 4 bonds around it. 4 bonds. The first carbon atom, look at it now. 1, 2, 3, 4. The second carbon atom, look at the bond. 1, 2, 3, 4. The third carbon atom, look at the bond. 1, 2, 3, 4. So it's saturated. All alkanes are saturated, but alkynes, they are what? Unsaturated at the carbon. So since it is saturated, it will only undergo substitution reaction. So that means one of the bromine will replace one of the hydrogen atoms. So but here the bromine will attack the second carbon atom, so we now have C, this one C, 1 2 3, that's hydrogen. I'm starting from here, that this CH3 I wrote now is this. Okay, now the second, so I started from the left hand side. The second carbon atom, bond, carbon, hydrogen. The hydrogen down will be replaced by bromine. Then the third carbon atom, bond, carbon, hydrogen, hydrogen, hydrogen. Are we together? Then I'm telling you the product. Okay. Then plus we are going to have two products. So the remaining atom of bromine, we having two atoms of bromine here. So one has replaced one hydrogen atom here, this hydrogen atom here. So the hydrogen atom that is replaced will come and join with the remaining bromine to form hydrogen bromide. With the remaining bromine to form hydrogen bromide. So these are the two products. And when you write this one very well, when you combine it together, it becomes CH3. Okay, and we combine this together, that's CHBr. Okay, when you combine this together, it becomes what? CH3. Are we together? So this one is the same thing as what we are given in the question. Okay, so CH3, CHBr, CH3, and this is what? 2-bromopropane. The product is what? 2-bromo, 1 2 3. So the 1 2 3. So the carbon 2. So bromine is attached to carbon 2. That's 2-bromopropane. All right, and this one is hydrogen bromide. So our correct option is what? Propane, for number 44. Now 45. Water from a river. Let me read 45. Organic chemistry. This one is under organic chemistry. Okay. 45. Water from a river. Say water from a river. They mention water. Let me drink water. Water is life. This is a purified water, pure water. It has been distilled. Impurities have been removed. Okay, 45. Water from a river contaminated by alkali. Water from a river contaminated by alkali waste. We have a pH of about. Water from a river contaminated by alkali waste. We have a pH of about. You know, when you look at the pH scale ranges from 1 to 14. Are you there? So it ranges from 1 to 14. So from 1 to 6, from 1 to 6 is acidic. 1 to 6, pH 1 to 6 is acidic. pH 7 is neutral. Are you there? Then pH 8 to 14 is what? Basic or alkali. So alkali or basic. That's on a pH scale. Okay, so and they said water from a river contaminated by alkali waste, we have a pH of about. Option A, 1. 1 is acidic. Option B, 3. 3 is between 1 to 6 acidic. Option C, 5. 5 is between 1 to 6 acidic. Option D, 7. 7 is neutral. Option E, 9. Yeah, 9 is between 8 to 14. So 9 is what? Alkali. Are we there? Or basic. So option E is the correct answer for number 45. Option E, 9. Let's go to number 46. Number 46. So which of the following mathematical representations for Graham's law? Which of the following mathematical representation is for Graham's law? Which of the following mathematical representation is for what? Graham's law. So now we are given different. We are given formulas in all the options. So which of the following mathematical representation is for what? Graham's law of diffusion. So the Graham's law of division states that the rate of division, right there, is inversely proportional to the square root of the vapor density. The rate of division of a gas is inversely proportional to the square root of its vapor density. The rate of division of a gas is inversely proportional to the square root of its what? Vapor density at constant temperature. So that means if you're having two gases, let's say we're having ammonia gas and then oxygen and carbon dioxide gas, the molecular formula, the molecular mass of carbon dioxide gas is that's CO2, that's 16 times 2, 32, that's 44. Are you there? That's 44. Okay, the molecular mass of ammonia gas is 17. Are you there? So the molecular mass of ammonia gas is lower than that of carbon dioxide. So ammonia gas will diffuse faster than carbon dioxide gas. So Graham's law of division states that the rate of division of a gas is inversely proportional to the square root of its vapor density or square root of its molecular mass at constant temperature. So mathematically, the rate of diffusion of a gas, now let's represent by capital letter R, is inversely proportional to the square root of its vapor density. Are you there? Vapor density. Let's use capital letter D, small letter D as vapor density. Are we together? So let's introduce a constant. When you introduce a constant, this sign becomes what? It becomes equal sign. So we have R equals to K over square root of D. Okay? So let's make K the subject. So K, which is the constant, equals to R multiplied by square root of what? D. Okay, so the constant means that R square root of D for two gases will be R1 square root of D1. So R1 square root of D1 equals to R2 square root of D2. Are we together? All right. So let's put all R's at the left hand side and all square root of D at the right hand side. How do you do that? Divide both sides by R2. Divide by R2. You have R1 over R2 equals to, that is at the left hand side. At the same time, divide both sides by square root of D1, because I want square root of D1 to come to this side. So divide both sides by square root of D1. So you have square root of D2 over square root of D1. Are you there? So you can write square root of D2 over square root of D1 as all is square root D2 over D1. So that means R1 over R2 equal to square root of D2 over D1. So the D2 over D1 will be inside the square root. Okay. So that means the rate of dilution of the first gas over the rate of dilution of the second gas is equal to the square root of the vapor density of the second gas over the vapor density of the first gas. So let's look at the options. Option A, R1 over R2 equals to square root D2 over D1. That's the correct answer. All of the options are wrong. Option B, R1 over R2 equals to square root of D1 over D2, wrong. Option C, R2 over R1 equal to square root of D1 over D2, wrong. Option D, R2 over R1 equal to square root of D2 over D1, wrong. Option E, R1 over R2 equals to D1 over square root of D2 equal to D1 all over square root of D is wrong. So option A is correct answer. R1 over R2 equal to square root of D1 equal to square root of D2 over D1. The D2 over D1 are inside the square root. So that is number 46. Option A is the correct answer. So let's go to number 47. 47, the density of this one is a calculation question. The density of a certain gas. The density of a certain gas is 2.0 gram per dm cube at STP density. So you are given density of the gas as 2.0 or 2 grams per dm cube at STP. Okay. What is the molar mass of the gas in grams? So we are looking for molar mass. Okay. Molar mass. That's question mark. They now give us in bracket, they give us molar volume of a gas at STP is 22.4 dm cube. Molar volume. So we're given molar volume as what? 22.4 dm cube at STP. Are we together? So it said the density of a certain gas is 2.0 gram per dm cube at STP, standard temperature pressure. What is the molar mass of the gas in grams? Are you there? That means in grams per mole. So we are given molar volume of the gas in the question in bracket at STP to be equal to 20.4 dm cube. These are the parameters. Are we together? So first and foremost, you know that molar volume, this molar volume equals to 20.4 dm cube. What was the implication? It means that 1 mole of any gas occupies a volume of 20.4 dm cube at STP. Molar volume. Molar volume is used for gases only. It's not used for solids. Neither is it used for liquids. So whenever you see molar volume, it's for only gases. It means that 1 mole of any gas occupies a volume of 20.4 dm cube at STP. So let's look at one of the formulas of molar concentration. Molar concentration. So molar concentration equals to molar concentration equals to number of moles all over volumes in dm cube. Molar concentration, or you say molarity is the same thing as molar concentration or concentration in mole per dm cube. So the formula is molar conc equals to number of moles all over volume in dm cube. So now, for the fact that we have been given molar volume, which is 20.4 dm cube, and I told you that molar volume, which is 20.4 dm cube, it implies that 1 mole of any gas occupies a volume of 20.4 dm cube at STP. So now we now use that to substitute here. So number of moles is 1 now. Is 1. Are you there? We say 1 mole of any gas occupies a volume of 22.4 dm cube. So number of moles is 1. Then all over the volume is now 22.4 already in dm cube. 22.4 already in dm cube. So let's divide that. So we have 1 divided by 22.4, and that gives us 0.0446. Okay, that is what? Mole per dm cube. Okay, mole per dm cube. So that is the molar concentration. But that's not the final answer. Are you there? We are asked to find what? Molar mass. Okay, so we now go to another formula of molar concentration. I've used formula for molar concentration. There's another formula for molar concentration. Are we together? Another formula for molar concentration is molar concentration equals to molar mass equals to mass concentration all over molar mass. So this is another formula for molar concentration. So molar conc equals to mass conc over molar mass. The unit of molar conc is mole per dm cube. The unit of mass conc is grams per dm cube. The molar mass, gram per mole. You see that. So molar conc, the unit of molar conc is what? Mole per dm cube. The unit of mass conc is what? Gram per dm cube. The unit of molar mass is what? Gram per mole. So we have gotten our molar conc as 0.0446. Let's substitute. Our molar conc is 0.0446 equals to. That's our molar conc, 0.0446. is 0.446. That's the molar conc. So equals to mass conc. I told you that the unit of mass conc is what? Gram per dm cube. Can't you see that mass conc is same thing as density here? A given density as 2 grams per dm cube. So mass conc is same thing as density. Are you there? That is physics in chemistry, chemistry in physics. Is that taking? All right. So mass conc is same thing as density. They have the same unit, as in the same unit, gram per dm cube. So our mass conc is 2. So all over our molar mass, all over our molar mass. So when you cross multiply and make molar mass the subject, you're going to have molar mass equals to 2. Are you there? All over 0.0446. And let's divide that. What do we have? 2 divided by 0.0446, and that has given us 44.8 grams per mole. Oh, grams per mole. Okay, let's look at the options. Option A says, don't forget the question, the density of a certain gas is 2.0 gram per dm cube at STP. What is the molar mass of the gas in grams? We are given molar volume of a gas at STP to be 20.4 dm cube in bracket. Option A, 11.2, wrong. Option B, 20.4, wrong. Option C, 22.4, wrong. Option D, 44.8, correct. Option E, 54.0, wrong. So our correct option for number 47 is option D. Now let's go to number 48. Number 48. Calculation in chemistry is simple. Calculations in chemistry is so simple. All right. So number 48. According to Charles' law. Oh my good. According to Charles' law, what is Charles' law? Charles' law states that the volume of a given mass of a gas is directly proportional to the absolute temperature, or you say temperature in Kelvin at constant pressure. So according to Charles' law, the volume of a gas becomes zero at so when I'm working with calculations under gas laws, either especially Boyle's law, Charles' law, pressure law, and all that, and you're given temperature in degrees Celsius, you must convert it to Kelvin. If you are given a temperature of 27 degrees Celsius for a particular gas in a particular calculation, you have to convert it to Kelvin. So you have to add 273 to that particular temperature for it to become what? Kelvin. Are we together? Now, how can we get a 0 Kelvin? For example, if you are given the temperature of a gas as 27 degrees Celsius, you have to convert it to Kelvin. I'm repeating it. So that means you have to add 273 for it to convert it to what? Kelvin. Are we together? Because when you look at one of these type of temperature scales, we have the centigrade scale, we have the Fahrenheit scale, we have the Rankine scale, we have the Kelvin scale. When you look at the Kelvin scale, the ice point of the Kelvin scale is 273 Kelvin, and the steam point is 373 Kelvin. Are you there? The ice point or the lower fizz point is 273 Kelvin. The steam point or upper fizz point for a Kelvin scale is 373 Kelvin. So 273 is the lower fizz point. So now that is where this 273 is coming from. Okay. So and I said that if you are given the temperature of a gas as, let's say, 27 degrees Celsius, you add 273 to it to convert it to what? Kelvin. Now, how can we get? Say according to Charles' law, the volume of a gas becomes zero at. So how can you get a 0 Kelvin? How can you get a 0 Kelvin? How can you get a 0 Kelvin? So look at option A. Option A say minus 100 degrees Celsius. Minus 100, if you add 273 to minus 100, you are going to have 173 Kelvin. That is not 0 Kelvin. Option B, minus 273 degrees Celsius. Minus 273. If you add 273 to minus 273, you get 0 Kelvin. That is the answer. Option B is correct. So option C is minus 373 degrees Celsius. So you can't get 0 with that. Option D is 0 degrees Celsius. If you add 273 to 0 degrees Celsius for option D, 0 plus 273 will give you 373. So option E, 273. If you add 273 plus 273, you can't get 0 Kelvin. So option B is the correct answer, minus 273 degrees Celsius, which when you add 273 to it, you have 0 Kelvin. Don't go and don't choose option D. Option D is 0 degrees Celsius, not 0 Kelvin. Are you there? So 48, option B is the correct answer. So let's go to number 49. 49. A brown ring test indicates the presence of test for ions. Are you there? This test for cations and test for anions. Are you there? So we have a brown ring test indicate the presence of copper. We are given Cu plus, that is copper 1 ions, Cu raised power plus. Our chemistry then presents Cu plus, I mean Cu plus at the top. So option A, copper Cu plus, that's copper 1 ions. No. So brown ring test is not for copper 1 ion. We use precipitating agents like sodium hydroxide solution or aqueous ammonia solution to precipitate copper 1 or copper 2 ions. Are you there? Now option B, iron 3 ions, Fe3 plus. No, Fe3 plus is not given us, it's not a brown ring test. So you know, for the iron 3 plus at the end of the day is giving us a green, you're giving us reddish brown gelatinous precipitate. Reddish brown gelatinous precipitate when you add a few drops of aqueous ammonia or a few drops of sodium hydroxide to the unknown, to the salt, to the solution of iron 3. To the solution of iron 3, you have a reddish brown gelatinous precipitate. Nitrogen 4 other, option C, NO2. Nitrogen 4 other gas. No, NO2. So nitrogen 4 other gas. No. Now, option D, NO3 minus. NO3 minus, that is minus at the top. NO3 minus, that is triazonitrate 5 ions. Good, that is the correct answer. So we use brown ring test indicate the presence of NO3 minus. NO3 minus. So NO3 minus is used to test for as a test for brown ring. Are you there? So how does it happen? So when you're in the lab, if you want to test for brown ring, when you're in the lab, you carry your test tube. When you carry your test tube, you add concentrated sulfuric acid. Freshly prepared concentrated sulfuric acid, that is H2SO4, are you there, to the unknown solution. The solution is already in test tube that you don't know. You want to test for its ions. It's anions. Are you there? The one of minus, not cations, the one of plus. Are you there? So when you have the solution of that in the test tube, then you add concentrated sulfuric acid. You add concentrated sulfuric acid and H2SO4. Are you there? Then you can also add iron 2 sulfate, iron 2 salt, okay, to it. So you can add iron 2 sulfate to it. Are you there? So at the end of the day, you have a brown ring test. There be a brown ring in between the two solutions, the bottom and the top. Are we together? So that is test for NO3 minus. So NO3 minus gives brown ring test. Now number 50 now. So option D is the correct answer, NO3 minus. Number 50, the final product of the reaction between C2H5OH. The final product of the reaction between C2H5OH and excess concentrated H2SO4 at 170 degrees Celsius is what? We're having C2H5OH, C2H5OH, that is ethanol. So reacting with excess H2SO4, sulfuric acid, tetrasulfuric acid at 170 degrees Celsius. 170 degrees Celsius, that is the operating condition. So they said, what is formed? See, there are two things here. If the acid is in excess, there will be dehydration. Water molecules will be removed from this ethanol, C2H5OH. Water, H2O, it will be removed from this C2H5OH if the H2SO4 is in excess. That means H2SO4 will be acting as what? A dehydrating agent, as I've told you before, dehydrating, removing the water molecules and at the same time affecting the chemical composition of the substance. So if H2SO4 is in excess, water molecules will be removed from the ethanol. Right there. So when you now remove water molecules from C2H5OH, that is remove H2O, you remove minus H2O from C2H5OH. So you have C2H4, right there, plus H2O. That's H2O has been, that's what you remove. Look at it. Carbon is 2, carbon is 2. Add these two together. Carbon is 2, carbon is 2. Hydrogen is 4. Hydrogen is 4 here. Hydrogen is 2 here in water. So 4 plus 2, 6. Hydrogen is 6. Come back to the ethanol. Hydrogen is 5 here. Hydrogen is 1 here. 5 plus 1. Hydrogen is 6. Now, oxygen. Oxygen is 1 here. Oxygen is 1 here. Is complete. So water has been what? Removed. So what we have is what? C2H4. Are you there? C2H5. The action has to do with 2 stages. So I don't just want to show that. But what I'm interested in is that to explain that the excess H2SO4 is acting as a dehydrating agent, not as a drying agent, okay? Because drying will not affect the chemical composition, will not break down the chemical. So C2H4 is ethene. That's ethene, E-T-H-E-N-E. That is the first member of the alkenes. So let's look at the options. But don't forget that if ethanol is in excess, so you have it as what? Ethane will be the product, ethane. If ethanol is in excess, you have it as C2H5O and C2H5. That's ethane. Are you there? Or you say diethyl ether. Is that taken? So that is if ethanol is in excess. But if the acid is in excess, you have what? Ethene. Alright, let's look at the option. It said the final product of the reaction between C2H5OH and excess concentrated H2SO4. Excess concentrate, H2SO4 is in essence, the acid is in essence. So we give option A, but 1 ion. That is wrong. Option B, epoxy ethane. That is wrong. Option C, ethene. That's the correct answer. Option D, ethyl. Option D, ethyl. That is wrong. Then option E, ethine, is wrong. So for number 50, our correct option is what? Ethene. E-T-H-E-N-E. For number 50. Let's go to number 51. 51. Okay. Which gas? Number 51. 51. Which gas is evolved when alkanol reacts with sodium? Which gas is evolved? Which gas is evolved? Wait, which gas is evolved? Which gas is evolved when alkanol reacts with sodium? Which gas is evolved when alkanol reacts with sodium? So we are having sodium, that is Na, plus ethanol, C2H5OH. Oh my goodness. Sodium dissolves in ethanol. Sodium also dissolves in water. Are you there? So sodium dissolves in ethanol. Sodium also dissolves in water. When sodium dissolves in water, we have sodium hydroxide with the libation of hydrogen gas. Are you there? So when sodium dissolves in ethanol, what do we have? We have C2H5ONA. Then plus C2H5ONA plus hydrogen gas. Let's balance like this. Half hydrogen gas. Half times 2, that's hydrogen is 1. So hydrogen is 1 here. Okay, so it's balanced. So this is what, when sodium dissolves, when sodium reacts with ethanol, it dissolves. Are you there? So the product is what? Sodium ethoside. Sodium ethoside. So C2H5ONA is called what? Sodium ethoside. Sodium ethoside. Sodium ethoside. Sodium ethoside. With the liberation of what? Hydrogen gas. That hydrogen gas. So that about the surface. Oh, that was number 51. Option A, ethane. It said which gas is evolved when alkanol reacts with sodium? The gas that is evolved. Option A, ethane, wrong. Option B, ethane, wrong. Option C, hydrogen, correct. Option D, nitrogen, wrong. Option E, oxygen, wrong. So correct option for number 51 is what? Option C, hydrogen, correct. For number 51. For number 51. So let's go to number 52. Burette tests. Burette tests. So burette test is carried out on organic compounds to determine the presence of what? Burette test is carried out on organic compounds to determine the presence of what? Option A, carbohydrate and lipid. No, carbohydrates. Carbohydrate is like starch. Are you there? So for you to test for carbohydrates, are you there? So we use iodine solution. So when you add iodine solution to the foodstuff containing carbohydrates or containing starch, are we together? So a blue black coloration is seen. That shows the presence of what? Carbohydrate or starch. Lipid, and they say option A say carbohydrate and lipid. No, lipid is a family name for fat and oil. So lipid is family name for fat and oil. And if you want to test for fat and oil, you can just put a drop of that substance on a paper, so it becomes translucent. Passes through it and becomes translucent. Or you use Sudan 3 solution. When you put 3 to 4 or 2 to 3 drops of Sudan 3 solution to the unknown solution, to that lipid, you have it will stain it red. That is test for fat or oil. So in which lipid is the family name. The option B, carbohydrate and protein. Carbohydrate, I've explained carbohydrate is wrong. Protein, yes, protein is correct. But the option B is carbohydrate and protein. So we can't choose option B because carbohydrate is there. Now option C, carbohydrate, wrong. Option D, lipid, wrong. Option E, protein. So burette test is for what? It is used to test for protein. So for let's say for the egg white solution or for the unknown solution, you add sodium hydroxide and you make the solution alkaline. The solution that you want to test whether it contains protein will be in your test tube. Then you add an alkali, sodium hydroxide. They might use sodium hydroxide. When you add alkali, few drops of it, then you add copper 2 sulfate. 1% copper 2 sulfate, drop by drop. You had 1% copper 2 sulfate, drop by drop. Then a violet coloration represents the presence of protein. Okay. There are millions reagents. Millions reagent is another chemical are you there that can be used. I can call it biochemical substance. Are you there? So it's another millions. So it's another chemical that we can use to test for protein. So that will give a white precipitate. When you add few drops of millions reagent to a solution and you have a white precipitate, and then when on eating, we now have a red precipitate. That is millions. That is test for what? Protein. Millions reagents. Okay. All right. Oh, number 52. Option E is the correct answer. Protein. 52. Option E is the correct answer. Now 53. Hydrogen is used for the following except. That's number 53. Hydrogen. Hydrogen is used for the following except. Okay. They want to test us on the use of hydrogen here. Option A. Conversion of coal to petrol. Chinekeme. How can we use hydrogen to convert coal to petrol? No. That's not one of the uses of hydrogen. It is obvious. Are there? So coal is a fossil fuel, is a solid fossil fuel, and petrol is one of the products obtained from the fractional distillation of crude oil. Are we together? So option A is the correct answer. Are you there? So let's just look at other options. Option B, extinguishing fire. Yes, hydrogen gas can be used to extinguish fire because it does not support combustion, unlike oxygen that supports combustion. Option C, manufacturing of ammonia. Yes, hydrogen is used to manufacture or to produce ammonia when it reacts with nitrogen gas. When it reacts with nitrogen gas in ratio of 1 to 3 to produce ammonia at a temperature of 250 degrees Celsius and which is a low temperature and a high pressure. Okay, so you have in the presence of finely divided iron as a catalyst, you have ammonia. You have that's one of the uses of what? Hydrogen. D, manufacturing of margarine. Yes, hydrogen is used to manufacture or produce margarine. So we call it hydrogenation of oil. Hydrogenation of oil produces what? Fat. Hydrogenation of oil gives what? Fat. Hydrogenation of oil gives fat. This is because oil is unsaturated, but fat is saturated. So just like the alkanes, and alkynes. The alkanes are saturated at the carbons. Alkanes and alkynes are unsaturated. So you have to add hydrogen to alkanes and alkynes for them to become saturated. So the same thing with oil and fat. Oil is saturated. Oil is unsaturated, while fat is saturated. So when you hydrogenate, that is, you add hydrogen, you pop hydrogen gas into oil, you have your what? Fats. Okay. So the other other things can be added into fat to make it margarine. Are you there? So that just to improve the flavor and other things. So option D is one of the uses of hydrogen. Option E, synthesis of hydrochloric acid. Yes, we can synthesize hydrochloric acid. That is when hydrogen gas reacts chlorine gas, we have hydrogen chloride gas. Are you there? So option A is not hydrogen is used for the following except conversion of coal to petrol. So hydrogen cannot be used to convert coal to what? Petrol. So number 53, option A is correct. 54, when a solid substance disappears. When a solid substance disappears completely as a gas on heating. When a solid substance disappears completely as a gas on heating, the substance is said to have undergone. They want to test out on change of state here. When a solid substance disappears completely as a gas on heating, the substance is said to have undergone a change of state. Option A, crystallization. No, crystallization is not talking about any gas. It's just a separation techniques, as I have told you before, to obtain a soluble solid from its solution. Are you there? B, decantation. Decantation is separation. Option B, decantation, wrong. Option A, wrong. Option B, decantation is a separation techniques in which an insoluble solid is obtained from its solution. You just decant like this. Okay, then option C, distillation. No, distillation is a separation technique also, in which is used to recover a soluble liquid from its solution. A soluble liquid from its what? Solution. So option D, evaporation. Evaporation is another separation technique that is used to obtain a soluble solid from its solution if the solid will not decompose on eating. So option E, sublimation. Sublimation is the correct answer. The process by which a gas, a solid substance changes into a gas without passing through the liquid state. A process by which a solid substance changes into a gaseous state without passing through the liquid state. That is what sublimation. We say that a solid or a substance are sublimed. Are you there? So, for example, iodine crystals, sublimes. Are you there? Dry solid ice, sublimes. Dry solid ice, sublimes. Iodine crystals, sublimes. Are we together? Ammonium chloride, sublimes. Are you there? Then camphor. Camphor is another example. Camphor, sublimes. Then there's another thing that they use at home. Air freshener is in solid form. Air freshener is in solid form. It's also sublimes. These are solids that are changing directly into the gaseous state without passing through the liquid state. So 54, option E is correct, sublimation. So don't forget that the dry solid ice, we use CO2. If you write the chemical equation, we use CO2 to represent dry solid ice. Okay, as in when it's sublimed, it gives CO2. So you say, so when it's sublimed, it gives CO2. That dry solid ice, when it sublimes, it gives CO2. So that's 54. 55. The shape of ammonia molecule is what? Oh my goodness. The shape of ammonia molecule is what? Look at ammonia, NH3. NH3, ammonia. It has nitrogen and hydrogen. So the central atom there will be nitrogen, surrounded by hydrogen. 1, 2, 3. Okay. So the valence electron of hydrogen, that hydrogen has 1 electron. It has only 1 shell. It has 1 electron. So hydrogen will supply its own 1 electron. Let me use cross. This hydrogen will supply its own electron. Let me use cross. Are you there? This hydrogen will supply its own electron. Let me use cross for bonding. Now, the atomic number of nitrogen is 7. Are we together? So when you break it down, it becomes 2, 5. That is the first shell takes maximum of 2 electrons. Then the remaining 5 goes to the second shell, which is 5. Are you there? So now these 5 electrons, that means the valence electrons of nitrogen is 5, which means that nitrogen has 5 electrons at the outermost shell. So nitrogen, for it to bond with hydrogen, are you there, to form that ammonia, so nitrogen will supply its own 1 electron. Let me use dot. Nitrogen will give this hydrogen 1 electron to becomes 2 electrons. 2 electrons make a bond. So nitrogen will also supply another 1 electron here. Nitrogen will also, I'm using dot to represent nitrogen, the electron supplied by nitrogen. Nitrogen will also supply its own 1 electron here. Right there. So these 2 electrons give us a bond now. This will give us a bond. This will give us a bond. So nitrogen supplies 3 electrons round. So but it's having 5 electrons at the atom's shell. So nitrogen is having 2 more electrons left. Is having 2 more electrons left. So those 2 more electrons that's left for nitrogen is what we call lone pair of electrons. So that means nitrogen has 1 lone pair of electrons. If you ask how many lone pairs of electrons does nitrogen does ammonia has? So ammonia. So how many lone pair of electrons does ammonia gas has? You have to say 1. How many lone pairs of electrons does water has? 2 lone pairs. You know, when you use this in my method, you see that it has 2 lone pairs. So now the significance of this is that this 1 lone pair of electron we push this bond. We make this bond to bend. We bend this bond. Okay, we're having this nitrogen. The 2 electrons here becomes 1 bond that gives hydrogen. This one gives us another bond, hydrogen. This one another bond, hydrogen. And these are still the lone pair of electron. Okay, so this is 2 electrons for nitrogen. That's 1 lone pair. So these are the bonds that are formed. So what is the function of this 1 lone pair of electron? It will push one of the bonds aside. It will bend one of the bonds. You bend this or it bends this. Are you there? So like this, nitrogen bond. This one is straight hydrogen. Okay, this one is straight hydrogen. Let's use this. So it bond like this, hydrogen. So this bond, which is horizontal, becomes, it bends. That is the function of that one lone pair of electron. Are we together? This one is purely horizontal. This bond is purely vertical, and this bond is bending at a particular angle. Okay, I think it's roughly 107 degrees. 107 degrees like that. It's 107, 117, 114 like that. So the bond angle. Okay, so ammonia. So the shape of ammonia molecule is option A, linear, is not linear. Option B, octahedral, is not octahedral. Option C, spherical, is not spherical. Option D, tetrahedral, 4 around, no. Option E, trigonal pyramidal. That's correct answer. Trigonal pyramidal. That's the shape of ammonia molecule. Trigonal pyramidal. Okay. Number 56. Let's go to number 56. Number 56 now. So for number 55, our correct option is what? Option E. Option E, trigonal pyramidal. Now number 56. The method that is used as a catalyst in the hydrogenation of oil. You know, before now I told you, at the hydrogenation of oil, you can hydrogenate oil to fat in the presence of nickel as a catalyst. In the presence of nickel as a catalyst at 180 degrees Celsius. Okay, so the method that is used as a catalyst in the hydrogenation of oil, hydrogenating oil to fat. From oil is unsaturated, fat is saturated. In presence of nickel as a catalyst at 180 degrees Celsius. So option A, copper, wrong. Option B, iron, wrong. Option C, lead, wrong. Option D, nickel, yeah. Option E, zinc. So our correct option for number 56 is option D, nickel. Nickel is a catalyst as used to hydrogenate oil to fat. Now 57. The position of an element in the periodic table is determined by O, according to modern periodic law. According to modern periodic law, elements are arranged. The properties of elements are a periodic function of their atomic number. In other words, the position of elements in the periodic table are determined by their atomic numbers. Are you there? Atomic numbers. So not atomic mass. So the position of an element in the periodic table is determined by its option A, atomic radius, wrong. No. Atomic radius, wrong. Electron affinity, no. So atomic radius is not the option, it's not the correct option. Are you there? So option B, electron affinity, wrong. Option C, number of neutrons on its atom. Number of neutrons on its atom. I don't talk about number of neutrons. Neutrons is the nucleus of the atom. Then D, number of protons. Number of protons on its atom. Number of protons on its atom. What is atomic number? The total number of protons in the nucleus of an atom. That is definition for atomic number. The total number of protons in the nucleus of an atom. So another way of saying atomic number is to say number of protons in the nucleus of the atom, or number of protons on its atoms. Are you there? So option D is the correct answer. Option E, relative atomic mass, wrong. So the position of an element in the periodic table is determined by its number of protons on its atom. That 57, correct option is what? Option D. Number 58, the following are uses of ammonia except uses of ammonia except we have diverse uses of ammonia. Are you there? So the following are uses of ammonia except option A, as a precipitating reagent. Yes, aqueous ammonia is used to precipitate insoluble salt. Insoluble salt. Are you there? That is what we see in the salt analysis. Salt analysis. Aqueous ammonia is used. So option B, in production of impression of margarine. Oh no. So you can't use ammonia in the production of margarine. Margarine is what is consumable, is what human being eats. Do you understand? So if you use ammonia as one of whether ammonia gas or aqueous ammonia as one of the ingredients in making margarine, you are killing people. Are you there? Is it the aqueous ammonia or ammonia gas? It has shocking, irritating smell. Shocking, irritating smell. So odor. So you can't. So option B is our correct answer. Are you there? So let's look at other option C. In production of plastic, yes, aqueous ammonia or ammonia gas is used in production of plastics. Are you there? So the function there is just to remove any fungicide, any insecticide. So that shocking, irritating smell will not make any insect, any fungicide, any fungi to stay. Do you understand? So option D, in refrigeration, yes, ammonia gas, liquefied ammonia is used as a refrigerant. Is used as a refrigerant, that is as a coolant in refrigerator. Are you there? So they can also use freon, F-R-E-O-N. That is another refrigerant, a coolant in refrigerator. Okay. E, in treating insect bite, yes, you can use ammonia to treat insect bite. Are you there? So option B, it said the following are uses of ammonia except. So option B, in production of margarine. So you can't use that. Option 58, option B is the correct answer. 59. 59 is a calculation question. Let's see how far we can go. 59. What quantity of current in amperes? What quantity of current in amperes will deposit 5.4 grams of aluminium in 8 hours during electrolysis? What quantity of current in amperes will deposit 5.4 grams of aluminium in 8 hours during electrolysis? So we are given in bracket, we are given aluminium, the atomic mass of aluminium as 27, we are given 1 Faraday of electricity as 96500 coulombs. Are you there? So we are given the atomic mass of aluminium, as 27, and we are given 1 Faraday as 96500 coulombs. Okay. Is there what quantity of current in amperes will deposit 5.4 grams of? They are given the mass, atomic mass. Well, let me write it like the atomic mass of aluminium. Let me use another symbol. Let me use let me say atomic mass of aluminium is given as 27. That is relative atomic mass. Relative atomic mass. Relative atomic mass has no unit. But when this atomic mass, it will be gram per mole. Atomic mass, gram per mole. Relative atomic mass, don't put units. Then 1 Faraday. Then we are not given, they said, what quantity of current in amperes will deposit 5.4 grams of aluminum? The main mass of aluminum given is 5.4 grams. Are you there? And then we are given time. We are given time T as 8 hours. 8 hours. Time T as what? 8 hours. So you convert your time to seconds by multiplying it by what? 3,600. That is 8 times 3,600, and that one is giving us what? So 8 times 3,600. So 8 times 3,600 gives us 28,800. 28,800. So 28,800 seconds. So you have to convert your time to seconds. Are you there? So see what which element is involved? Aluminium. So what is the valence electron of aluminium? 3. Aluminium is 3. The atomic number of aluminium is 13. When you break it down, 2, 8, 3. First share takes 2. Second share takes 8, maximum of 8. Then third share takes the remaining 3. So the valence electron, the electron at the atom share is 3. Are we together? Is 3. So that means 3 Faraday, are you there, of electricity, are you there, is required to deposit 1 mole of aluminium. Your first line must always be the quantity of electricity required to deposit 1 mole of aluminium. That is Faraday's law of electrolysis. That is what Faraday's first law of electrolysis. Are you there? So we say that the mass of an element discharged during electrolysis is directly proportional to the quantity of electricity passing through it. So when you're solving calculation on that electrolysis, so the first line would be you compare the quantity of electricity with what? With the mole of the element involved. If they say aluminum nitrate, aluminum sulfate as the electrolyte, are you there? So it is aluminum that you pick, just aluminum as an element. So that will be your first line. The first line, say, so the quantity of electricity for the first line would be the valence electron, the valence electron of that element involved. And the element involved is aluminum, and the valence electron of aluminum, which means electron at atom shell, is 3. Now say 3 Faraday. Are we there? So if this copper 2, copper 2 salt. So copper 2 salt, it has 2 plus, that's 2. You say 2 Faraday. Are you there? So if the silver is Ag plus, that means invisible one is there. You say 1 Faraday. Are we together? If this gold salt, Au, we have Au, the association number of Au, gold is plus 3. You see 3 Faraday. So aluminum is also plus 3 Faraday. So 3 Faraday of electricity is required to what? Discharge 1 mole of the elements. Either, and 1 mole of the element is its relative atomic mass, or its atomic mass if you want to put units. Relative atomic mass, no unit, as I've said. Atomic mass, gram per mole, I've told you before. So now 1 mole. So 1 mole of that element is its atomic mass, or is its relative atomic mass. Are we together? So we are given the relative atomic mass as 27. Let's put 27. Put grams there, because now we are working in mass. Are you there? In mass. So 27 grams. Okay. So this 3 Faraday, you change this Faraday. This 1 Faraday, this 3 Faraday means 3 times. It means 3 times 1 Faraday. Mathematically. So 3 times 1 is 3. So it means that this Faraday, you turn it to 96500 coulombs. 96500 coulombs. So instead of writing 3F, you write 3 times 96500 coulombs. So that is 3 times 96500 coulombs. So this quantity of electricity, coulombs is the unit of quantity of electricity, Q. So C is a unit of quantity of electricity. So this Faraday deposited 27 grams of aluminium. So this side is for coulombs, this side is for grams. So now we now come back, look at the given parameter. They are given 5.4 grams in the question. 5.4 grams in the question. So you put the left hand side is in coulombs, the right hand side is in grams. So this 5.4 grams will come to where? Is it left hand side or right hand side? It will come to the right hand side, because right hand side is in grams. So we have 5.4 grams here. Are you there at the right hand side? Then with what here? Question mark. Are you there? Question mark. Okay? Question mark. So you always have 2 lines like that. Okay? In solving. So that question mark, let it be any alphabet of your choice. So let me use X. Okay? So cross multiply like this and make X the subject. At the end of the day, you have X equals to 3 times 96500 multiplied by 5.4 all divided by 27. So let's see what that gives us. So that's 3 times 96500, okay, times 5.4, that gives us this, divided by 27, 57,900, 57,900. So S equals to 57,900 coulombs, because we are the left hand side. 57,000, say 3 times 96500 times 5.4 equals to, divided by 27, 57,900 coulombs. So coulombs, capital letter C, is unit of quantity of electricity. Are we together? So according to Faraday's law, are you there? So we have M is equal to ZIT. That's Z is, we have M equals to ZIT. Are you there? Or we say M equals to ZQ. Okay? That is, if that Z is a chemical equivalent. Is a chemical what? Equivalent. So in physics, you always be given the chemical equivalent, which is Z, are you there, as a constant. It is peculiar to each element, then you substitute and solve. Are you there? So, but now what does Q represent? Q represent IT. So I just brought this one was just by this one was just by the side, by the wayside. So Q equals to IT. That's what I want to use now. Q equals to IT. This is the formula. Q is equal to IT. Are you there? So Q is a quantity of electricity, I is a current, and T is the time. So our Q, the unit of our Q is coulombs, the unit of our I is amperes, and the unit of our time is seconds. So what's our Q? We have gotten Q as 57,900 coulombs. So 57,900 substituting equals to, the step we should find what? The second says, what quantity of current in amperes will deposit 5.4 grams of aluminium in 8 hours during electrolysis? So what quantity of current? We're looking for currents, I. Then multiplied by T. Our time in seconds is 28800. 28800. So making I the subject, so I becomes 57900 divided by 28800. So an I becomes, so let's divide that. That is 57900 divided by 28800. That gives us 2.0104. 2.0104. Approximately 2.0104. This is approximately 2 amperes. 2 amperes. 2 amperes. So that's the, let's look at the options. What quantity of current in amperes will deposit 5.4 grams of aluminum in 8 hours during electrolysis of that aluminum 27, 1 Faraday, 950 coulombs? Option A, 2. That's the answer. Option B, 4. Wrong. Option C, 6. Wrong. Option D, 8. Wrong. Option E, 10. Wrong. So now let's go to 59. The correct option is option A. Let's go to number 60, which is the last question for the objective part. Are you there? So then in the next part, in the next video, so we'll go for the theory aspect of this examination. Are you there? That is National Examination Council, NECO. So let's go to that number 60 is a calculation question also. Okay, it's a calculation question. Oh, number 60 says the volume of a gas at 310 Kelvin was 200 centimeter cube. The volume of a gas at 310 Kelvin was 200 centimeter cube. Determine its temperature in Kelvin if the volume becomes 250 centimeter cube. The volume of a gas at 310 Kelvin was 200 centimeter cube. Determine its temperature in Kelvin if the volume becomes 250 centimeter cube. They are comparing volume and temperature. So the relationship between volume and temperature in Kelvin is given in Charles' law, is seen in Charles' law. And Charles' law states that the volume of a given mass of a gas is directly proportional to its absolute temperature, or you say temperature in Kelvin, provided that the pressure remains constant. So, and the formula is V1 over T1 equals to V2 over T2. Okay, is that the volume of a given mass of a gas is directly proportional either to the absolute temperature at constant pressure. So let's look at the parameter. The volume of a gas at 310 Kelvin, that is T1. We're given T1 as 310 Kelvin. You are lucky that temperature is already in Kelvin, but if the temperature is in degrees Celsius, you convert it to Kelvin by adding 273. The volume of a gas at 310 Kelvin was 200 centimeter cube. That is V1. V1 is 200 centimeter cube. Determine its temperature in Kelvin. So if determine its temperature in Kelvin, then that is unknown. That is the second temperature, T2, equals to question mark. If the volume becomes 250 centimeter cube, that means V2 is 250 centimeter cube. So just conveniently and confidentially substitute. V1 is 200 over T1 310 equals to V2 250 over T2 question mark. So T2. So cross multiply and make T2 the subject. Multiply and make T2 the subject. So we have T2 equals to 310 multiplied by 250 over 200. So at the end of the day, so when you use a calculator for that, you have 310 multiplied by 250 give us this, divided by 200 give us 387.5. 387, that's 387.5 centimeter cube. Okay, let's look at the options. So option A 116 wrong, option B 273 wrong, option C 300 wrong. Are we there? Option D 370 wrong, option E 388. 387.5 approximately is 388 centimeter cube to the nearest whole number. Are you there? So option A 116 wrong, option B 273 wrong, option C 300 wrong, option D 370 wrong, option E 388. So for number 60, option E is the correct answer. So we have come to the end of the objective part of NECO. So the next video before the theory aspect of it. So thank you for listening. Okay, so don't forget, so my number remains 090745263111. You WhatsApp, you call, you message. Okay, this is Campus Academy. In physics, in chemistry, in maths, further maths, technical drawing, we are there. Bye for now. Drinking my water.